Hello everybody and welcome to our new tutorial. In the last tutorial we already described how to convert the printed map on hard copy into the digital format using NeuraMap software, and we explained how to export this file into contour interval or contour values, as well as fault polygons. Sorry. Now let's go for Petrel and show you how to construct a 2D map, 2D or 3D map, a structural contour map using the exported files. I'm using, as usual, Egypt red belt for my project, because I'm familiar with this XY in meter and Z in feet. Let's save field unit and select Egyptian red belt coordinate system. Then click OK. Okay. You want to refine OK, XY again, XY. Now XY in meter and Z in feet, as we agreed before. Okay, then click OK. Just right click here to import the exported file from NeuraMap for contours values. Double click and choose general line and point, and double click here. The software will ask you which column refer to X and Y and Z. Actually, for X value we need to choose X column number 1, and Y value column number 2. As we discussed before, this one is count for digitizing, count for how many digitized set for contours, how many contours. We can forget this, the third column, and choose directly the fourth column, which is referring to Z value column number 4, and click OK for all. We leave this template as the same, and line for others, and no change for file CRS, because we have XY in meter from NeuraMap. You should negate Z value, because Z value almost in negative value, but digitized one is positive. Then click OK for all. Now we already uploaded or imported the approach contour values. Just right click again and import the fault file. We have to choose the same file type, which is general line or point. Then click open. Because we have only one fault, we can leave X. We use only X and Y, and only one polygon, so no need for column number 4. You have to choose for a while none, but later on we can use a file with multiple faults, so no problem, we can show this later on. Then click OK for all. Okay, now no need to negate Z value, because we have already fault polygon, not a depth. And choose for line type, we have to choose fault polygons. Then click OK for all. Now the fault and the contour already imported. Let's check what is inside, and go for 2D window as usual, and just click on the contour values. We have already contour here, and the imported fault. Okay. Now you can convert these contours into surface. Before getting into surface or generating map process or surface, we have to make a polygon, which is selling the software you need to bound the reservoir with this polygon. Let's go for tool palette and choose polygon editing and new polygon. No need for this. New, and define the limit for the reservoir with this polygon, which is the last contour or deepest contour in the bay area or the reservoir, as well as the isolating fault. Then double click here, and this polygon number 1. Then go to stratigraphy and make surface. Will ask you which input data for surface. We have to tell them about G as a surface of this contour. For boundary, of course, no. For boundary, we have to choose this polygon and click next. The resulted surface would be displayed here. There are many algorithms for generating this surface, but for a while we can use automatic formatting and see the results what happening. Okay. Since this one is not realistic and which is not accepted from GNG point of view, we have to go manual selecting to use user define, and you can leave the X minimum and Y minimum, maximum and values. This value you can leave this because this captured from the input file. For X incremental Y and Y, you can use 1 instead of 50, more resolution or more accurate, and then click apply. Okay, now this one is more realistic surface. We click to accept this one. Just uncheck the rest. We can deal with this only. We can deal with this generated surface. Just right click and style top and bottom. Top, of course. Okay, you can leave this one as it is. Solid, green contour lines. Okay. For coloring, you can use local private and limit the top and bottom to, let's say, -4000, and here is -4100. It's a matter of sensitivity. Just go for setting, you can see the minimum and maximum value, and you use this for displaying the color code. For a while, we assume the maximum, minimum or maximum from 4400 to 4000. Okay, -44. Okay. Okay, now it looks more realistic, and you can display it in either 2D or 3D or whatever. You see what is displayed in 3D view. Click here, yes. And choose the value for ratio between X, Y, and Z. It should be 1. Okay. Now you have the surface ready for any further process. Okay. Thank you for watching and have a nice day.